In this unit, we'll be talking about the classification of computer networks by functional relationship. Computer networks may be classified according to the functional relationships which exist between the elements of the network, for example, into active networking, client-server, and peer-to-peer architectures. Active networking is a communication paradigm that allows packets flowing through a telecommunications network to dynamically modify the operation of the network. It comprises of active hardware capable of routing or switching, as well as executing code within active packets. This differs from the traditional network architecture, which seeks robustness and stability by attempting to remove complexity and the ability to change its fundamental operation from underlying network components. Network processors are one means of implementing active networking concepts. Network processors are typically software programmable devices and would have generic characteristics similar to general-purpose central processing units that are commonly used in many different types of equipment and products. Network processors are used in the manufacture of many different types of network equipment, such as routers and switches, firewalls, intrusion detection devices, intrusion prevention devices, network monitoring systems, and so on. Client-server is network architecture which separates a client, often an application that uses a graphical user interface, from a server. Each instance of the client software can send requests to a server. Specific types of servers include web servers, application servers, file servers, terminal servers, and mail servers. While their purposes vary somewhat, the basic architecture remains the same. Although this idea is applied in a variety of ways on many different kinds of applications, the easiest example to visualize is the current use of web pages on the Internet. For example, if you're reading an article on Wikipedia, your computer and web browser will be considered a client, and the computers, databases, and applications that make up Wikipedia will be considered the server. When your web browser requests a particular article from Wikipedia, the Wikipedia server finds all of the information required to display the article in the Wikipedia database, assembles it into a web page, and sends it back to your web browser for you to look at. A generic client-server architecture has two types of nodes on the network: client and servers. As a result, these generic architectures are sometimes referred to as two-tier architectures. Some networks will consist of three different kinds of nodes: client, application servers, which process data for the clients, and database servers, which store data for the application servers. This configuration is called a three-tier architecture. The advantage of an n-tier architecture compared with a two-tier architecture or a three-tier architecture with a two-tier architecture is that it separates out the processing that occurs to better balance the load on the different servers, which means it is more scalable. The disadvantages of n-tier architectures are: it puts more load on the network. It is much more difficult to program and test software than in two-tier architecture, because more devices have to communicate to complete a user's transaction. Advantages of a client-server architecture are the following. All the data are stored on the servers, so it has better security controllability. The server can control access and resource to make sure only let those permitted users access and change data. Disadvantages of a client-server architecture are the following. Traffic congestion has always been a problem since the first day of the birth of a client-server paradigm. When a large number of clients send requests to the same server at the same time, it might cause a lot of troubles for the server. The more clients there are, the more troubles it has. client-server paradigm does not have as good robustness. When the server is down, client's requests cannot be fulfilled. A peer-to-peer system is a distributed system whose component nodes participate in similar roles and are therefore peers to each other. Peer-to-peer can be viewed as decentralized network architecture. In contrast, a client-server architecture implies a sharp distinction between the clients which request and consume services and servers which provide services. Even though the nodes have similar roles, there may still be some structure to the peer-to-peer system, and it usually possesses some degree of self-organization where each node finds its peers and helps maintain the system structure. This makes a peer-to-peer network node more complex than a client in client-server system. The main benefits of a peer-to-peer system are scalability, fault tolerance, and the lack of resource bottlenecks in servers. An important goal in peer-to-peer networks is that all clients provide resources, including bandwidth, storage space, and computing power. Thus, as nodes arrive and demand on the system increases, the total capacity of the system also increases. This is not true of a client-server architecture with a fixed set of servers, in which adding more clients could mean slower data transfers for all users. The distributed nature of peer-to-peer networks also increases robustness in case of failures by replicating data over multiple peers, and in pure peer-to-peer systems by enabling peers to find the data without relying on a centralized index server. In the latter case, there is no single point of failure in the system.